you have more space on the top of page 144, and we'll give it a title. Questions with more than one square root. So here's our example. We have the square root of x plus 3, and it's equal to the square root of x minus 5 plus 2. So we have two square roots. Now normally, the strategy in a square root equation is to isolate a square root and square, but what happens if you have two of them? Well, the strategy still stays the same, and we'll write out our strategy for these ones. So we're still going to isolate one square root. And square. So this seems like exactly the same strategy. The problem with the strategy, though, is that it doesn't get rid of all of our square roots. So when we do this, this will only get rid of one square root. These are a little bit more tedious because we're going to have to isolate again and square again. So what does that mean? It doesn't matter which one you want to isolate. Currently, my square root of x plus 3 is already by itself. So it makes sense. One of them is isolated. I can square both sides. Now, when showing the work to square both sides, put the whole side in brackets and square it, which means this whole side has to go in brackets and square as well. Which means you're going to get quite nicely on the left side just x plus 3. But on the other side, squaring means multiply by itself, so I'm going to actually write it out, that it means this times by itself. And if I'm going to multiply a binomial times a binomial, I have to FOIL, do all of my arrows. I can show my arrows here. This gets multiplied by this. This gets multiplied by this. This and this. So I'm going to do that math. I get x plus 3. Nicely, can you see that the first arrows, square root of x minus 5 times the square root of x minus 5, I'm going to just keep it in brackets so it's together. It's just going to be x minus 5. That's nice. Technically, I might need absolute values here, but this is where mathematicians be like, you know what, if you don't have the absolute values, I'm not worried about it. We're going to be okay. We're trying to solve this. Sometimes when we don't do things like absolute values, as long as we're checking our final answer in the end, we're sort of covering ourselves for making possible mistakes. Okay? So I get x minus 5 there, but then I'm going to have this, and this is 2 square roots of x minus 5, and then the inside ones will give me another 2 square roots of x minus 5, and finally 2 times 2 is 4. So the nice thing is that I got rid of my square root on the left side, but I didn't get rid of all of my square roots. However, I did reduce my original equation had 2 square roots, and because these are like terms, I reduced it to 1 square root. Again, this only gets rid of 1 square root. We still will need to isolate again. So what I'm going to do in my combining of like terms, I'm going to at the same time isolate, and I'm going to only leave this 4 square root of x minus 5 on the right. Can you see that you'd have to subtract your x on this side? And your x's would go away. I have a minus 5 and a plus 4, which would be a minus 1 on the right-hand side. If I move that minus 1 to the left-hand side, I'd have to add 1 to both sides, and I would get 4. I could technically square here already, because I have a single term. In some ways, my square root is mostly isolated, but I could also divide both sides by 4 to really isolate it. So we squared both sides, got rid of 1 square root, still left us with 1 square root, but now that you have only 1 square root, now it's back to our regular strategy, where we need to isolate that square root, and now again, I'm going to square both sides. So I'll put this side in brackets and square, this side in brackets and square. 1 squared, of course, is 1, and the square root and the square root go away, so we get x minus 5. But we're not done until we've checked. Because it might be an extraneous root. It might be, tell you, if you feel like swearing after doing all of that work only to find out that the only answer you got does not work, kind of frustrating. Like I should have just looked in the answer key and saw it's not going to work, why bother? But here, let's check it. So I'm going to go to my left side. My left side, original equation was just the square root of x plus 3. So I replaced the x with 6. 6 plus 3 is 9. Square root of 9 is 3. No negative square roots. Seems like we got an answer on the left side. Right side was the square root of x minus 5. So I'll plug in my 6. 6 minus 5 plus 2. This will give me the square root of 1, which is 1 plus 2. Oh, yes. We are happy. The left side and the right side are the same. And so we know that this answer is correct. All right, I'm just going to check if there's any double square root questions that have numbers.
12.
Number
Excuse the
12,
interruption.
but they
Would
don't have
any
any
grade
adding.
9
12
who
is
have
still.
not done their course selection, please report to B5. Any grade 9s who have not done their course
I'll
selection,
put
please
some-
report to B5.
So there's none with the extra adding. I will put some of those probably on your review, but you can do number 12 for that.